Hello, everybody. We are back. Happy Wednesday, the hump day, and yeah, today, September of 2018. Uh, yeah, I got off work on a more or less regular time, like 5:30, and then I went to a political meeting, a very small local meeting. Okay, and yeah, it's good. To me, that's my social life. Because I don't really hang out with anybody. So, just it's always nice to meet new people. People outside work is good. Um, anyway, I see that mega thing in this rose hip, and I really hate these guys. Okay, I mean they are dead because they are all like deep in, been dipping in the alcohol for a long time. So well, I call them maggots because they look like maggots, but I don't think they are actual maggots, like fly. I don't think so. There's some kind of worms. I hate looking. I hate the look of them. They're so ugly. Oh my goodness, they just look so horrible. Anyway, but yeah, I'm sure they're edible. They're not toxic or anything. They're just damn ugly. Okay. Oh, this worms, man. And anyway, yeah, this wild berries. Yeah, they do have bugs in there. Okay, so but they're mostly harmless. Okay, so today, last time we talked about happiness, right? So, what makes you happy? Does money make you happy? Well, if you, okay, because we kind of omitted, skipped this important discussion. I thought about doing it, but we ended up not doing it because we were distracted by all this Donald J. Trump stuff. Okay, so if you have, let's say you inherited money, okay, or you just have some money, whether you earned it or not. Let's say you have $10,000 in your bank, you're saving, you're checking, okay, and you have had this for a very long time. So this money does not make you happy because there's no change. You didn't lose it, you didn't gain it. It's just constant. Let's say over time it's like just inflow and outflow, right? It's like this is like some kind of jar or cup. So money coming in, money going out. You work, so you gain some money, wage and salary, right? So money coming in, and there expense. You have expense, right? Your bills, you know. So this is personal finance, and it's just like companies, corporations, because most corporations, the vast majority, run on debt, right? Accounting equation: what asset is equal to liability plus equity, and equity, unless you are sole proprietor, if you are not a sole proprietor, then equity is kind of distributed over several investors, right? Even if your company is a small company, still probably you have some equity share distributed at people other than yourself. And of course, you have a liability, which is debt, like short term loan, long term loan, that kind of stuff. So, like, yeah, 90% of companies' financing is through debt or equity, and mostly equity is other investors, so it's kind of like debt, anyways. So, and your personal financing is pretty much the same way. You have bank, you have your mortgage, right? Unless you it's all paid off, but by then you are pretty much retired or you don't have many years to live anyway, right? So if you are in your middle age, if you're young, well, if you're young, you don't have much debt, right? You're probably a renter in your 20s, early 30s. You're a renter, so but still, you probably have a car loan if you own a car, right? So yeah, and if you're in your 40s, probably you have your first home, or in your mid 30s or late 30s, whatever it is nowadays. Okay, you have your first home and your car, so it's on debt. Mortgage is just a debt. Your bank pay off your car, your home, your house. Then so they are the creditor, you are the debtor. So you pay interest and a little bit of principal. Over for a car over a decade, for a house over 3 decades, right? That's standard, isn't it? Isn't it? So yeah, but that's side. That's a side. So yeah, you have. Let's just forget about all that stuff. Let's say you have your savings account or checking account, right? Bank account. Money coming in, going out. You make some money and it goes out as an expense, right? But let's say it just stays at $10,000 for a very long time. So it doesn't make you happy. You do have disposable income. I mean, disposable money, but it's neither increasing nor decreasing. But let's say you have some extra income, okay, coming in. So this money, part of money, start to increase. That may make you happy a little bit because you are getting richer and richer, right? Or the other way, uh, let's say you are making money but you are spending more. So now this part of money is decreasing. They may make you a little bit uncomfortable or, you know, a little bit uncomfortable, like pain, which is a form of pain, okay? Insecure, maybe, nervous, okay? So if more money is coming in than going out, then yeah, you probably will feel secure, more secure, okay? Safer, perhaps. So the point is, it's the change. Is it increase or decrease in the pot of money? The change. It's not the money itself. It's the change in money that can make you happy or unhappy. So happiness, it's just like we talked about this temperature, body temperature. We don't feel cold when the temperature, our body temperature, stays the same. But if the body temperature here on this spot goes down, then we feel coldness, the pain of coldness. Warmness, you know, it's also a change. We're like hotness, yeah, temperature, local temperature in this skin, patch of skin goes up, then we feel the hotness. Okay, other than that, we feel neither cold nor hot. Okay, it's about change in temperature, body temperature. Okay, it's just like this. So we're talking about money, making you happy, unhappy, secure, insecure. We're talking about body temperature. Okay, so it's, feeling cold or hot, or when do you feel good about the temperature? Let's say it's very hot day and you're jumping into your pool with cold water. Oh, it feels so good, right? Or taking a shower with cold shower. Oh, it feels so good. It's the change in temperature. It was hotter than your comfortable level. Then now it's cooling down. That change, okay? Why did you feel unhappy about the hot temperature? Because it's hotter than what you're comfortable. That change, difference. And then, okay, you saw me in my suit and tie, so I'm gonna put on this thick jacket, okay? I am feeling cold now. And yeah, when do you feel good? Have this good warm feeling. It's when it's cold outside and you just got home. It's nice and warm or heated up, Then you feel good because that change, the difference. You're unhappy because it's colder than what you are comfortable with. That's the negative change. That's why you felt bad. when you go outside in winter in the morning to work, you because you used to be comfortable in your room temperature and now you're going outside in the winter morning, so it's negative change, right, in temperature, and the temperature going down, it felt bad, unhappiness. Okay, then you come home and your house is nice and warm and outside was miserably cold, so now you're unhappy because it was too cold outside, and then you come home and now it's warm. That change, positive change, it makes you happy. Temperature goes up to your comfortable level and your feeling goes up too. Okay, now we are kind of getting in the realm of calculus. Okay, so calculus is all about change. Okay, so there's this German mathematician Leibniz, and English, of course, English mathematician and physicist Isaac Newton. Okay, so I think they kind of knew each other probably, but they invented this mathematics of calculus nearly at the same time. Well, so the story goes. Okay, but who knows what happened. But in the history of science, that kind of happens quite a bit, quite often. Two people coming with invention, mathematical or physics or otherwise, nearly at the same time. That does happen, okay? Because they're kind of in the same field, so there's this common problem that other people are working on independently. So yeah, it can happen. It's not miraculous or too unexpected that they find out the solution nearly at the same time. They're about same intelligence and they all know those. They encounter those common problem around the same time, and so probably you take about the same time to solve that problem, right? So yeah, it's not too unexpected or too surprising. Two brilliant mathematicians, come with a solution at the same time, but their notation is kind of different. Okay, so so we're gonna do some calculus. Okay, so don't get scared if you don't know about it because it's not that hard. I make it easy for you. Okay, trying to see if there's a bug or a seed inside of that. I think it's a seed inside of that rose hip. It's hard to tell. Oh, but it tastes so good. That's why bugs like it too. Rose hips. Okay, so calculus is about change. Okay, so let's think about the position. Okay, so one dimension, all right? One dimensional coordinate. Okay, so there's 0, there's -1, there's a +1. Let's say it's left, so it's a west, east. You are on a highway. Okay, +1. Here is where you live, and here is where your workplace is. So yeah, this is that's why you assign this positive direction, because you mostly go there. You don't go to backcountry very often. Maybe on the weekends, okay? But yeah, so now, so there's this position, okay? 1, 2, 3, -1, -2, -3, okay? Let's say your friend next door lives right here in the coordinate 1, okay? And this friend of yours travel from 1 to 3, and this is x-axis. Okay, so this is x1 equals 1, x2 equals 3. Now x2 minus x1, because this guy traveled from his house to the workplace where you and he work together, your office. X2 minus x1 is equal to what? 3 minus 1 equal 2, right? We call it delta x, okay? Delta is differential, the difference between two x coordinate. Okay, that's difference, all right? Now, we introduce a concept of division, speed, or velocity, okay? So, what's definition of velocity is velocity is equal to delta x divided by time, okay? Speed, how fast you go to, okay? So, yeah, that's all there is, okay? And but acceleration is this acceleration a. They're both vectors, okay? And x is we call it positional vector, okay? Because x1 is this, x1, x2 this. One, it has length 1, length 3, so the difference of these two vectors is also a vector with length 3, and then they are all pointing to the same direction, east, okay? And they're all vectors, all right? They're all vectors, okay? Difference of two vectors is also a vector, okay? So yeah, the whole thing is a vector. Okay, time is a scalar though, and it's not just scalar, it's always positive, or it could be zero, it's non-negative, okay? Because time is, okay, so in 4-dimensional space you have x, y, z axis, that's 3-dimensional space, plus time axis, that's 4-dimensional axis, but time is not the same as x, y, or z. Time is a little bit different because it's only unidirectional, it's not bidirectional. Along the x-axis you can go front and back, right? But time has only one direction, it only goes forward. There's no such thing as time machine, all right? So in the special theory of relativity, Einstein basically said it's impossible to do the time traveling because it would result in some imaginary number, or negative one inside of the square root, something like that, okay? So yeah, so calculus, yeah, we always have said that humanology is humble, so we deal with just addition, subtraction, multiplication, sometimes division, and we mostly deal with one-dimensional space or two-dimension, and also we do deal with not some fancy statistics, but just elementary combinatorics, okay, some basic probability. Well, that's the start, okay, that's a start, but let's go one step further. Let's bring some calculus into humanology, okay? We covered enough basics, okay? We have to always move forward, and okay, so it's about time, okay? So we're gonna introduce some calculus to humanology, all right? Now, acceleration is delta v over t. It's change in speed. I mean, it's, again, calculus is easy, okay? Because you know what your position, your location is. You know what velocity is. Speed. Speed is amplitude of velocity. Okay, it's just if this is absolute symbol, the bar or surrounding it, it makes everything positive. So it's a scalar. Speed is a scalar. All right, and yeah, it just disregards the direction and takes out the amplitude, the size. magnitude. Okay, that's what speed is. Okay, you don't care about direction. Okay, so and acceleration is a vector, and so you're familiar with this concept of acceleration, speed, location. Okay, yeah. So that's that. Um, and Yeah, so that's the basics. Okay, so with your permission, I'm gonna erase all this. Okay, because I don't want to write here like reaching out far. It's too inconvenient. All right, so you can always rewind and review if I'm going too fast. Okay, so now so like velocity acceleration. Okay, so in a gravitational field. Okay, so like technically, if you want to be really accurate, um, every point above the ground have different acceleration, different gravitational acceleration. We call it g. Okay, but the difference is very minuscule because Earth is a huge object. Okay, so compared to the size of the Earth, the distance from here to here is minimal. It's like trivial. It's like ignorable. In legal term, de minimis. Okay, I think it's from Latin or something. So S equals to st, but let's say this acceleration is constant. Okay, it's a good approximation because this gravitational acceleration, we call it g, is it does vary according to the altitude, but because Earth is so big, it's pretty much similar. Okay, to each other. Okay, unless you go way up there. All right. Let's say there is an object that's falling down. Like I'm gonna cap this. Okay, if I just drop it like this, I mean, I want to catch that shit. I'm not good, very good at catching. Okay, so if free fall. Okay, free fall. All right. Or you have some electromagnetic, you have magnetic field. Okay, magnetic field. You have north end of magnet here, south end and magnet here. Okay. Well, not magnet because magnet isn't really. It always have north and south pole on one body, so that's not a good example. Yeah, not a good example. Let's say you have an electric field, because electric field in the electronics, you can have point charge that's only positive or only negative. Okay, so you have this field, electric field. So positive you repulse, and minus plus you attract. Okay, so this positive point point charge with 1 coulomb, yeah, will move into this direction. Okay, and in the Newton's equation, F equal ma, right? So A is equal to m F over m, right? Meaning, if force field is constant, you have one fixed force like gravitation, then the acceleration will be constant, okay? But it will accelerate. Like, for example, again, if you're lost, don't worry, it's easy concept. This pen is at with the speed of 0. Forget about Earth moving around the sun or Earth rotating itself. Forget about all that. Okay, we are in the universe. Okay, so this pen is not moving. It's at the speed of 0, velocity of 0. But once I drop it, the speed becomes bigger and bigger, from 0 to 0.1 meter per second, and then 0.2 meter per second, like from 0 to 0.001 inch per second, then 0.002 inch per second, then 0.003 inch per second. It accelerates, okay, because there's constant this force, okay. And if you have very heavy object, okay, if you have a very heavy object, okay, so let's talk about gravitation, okay. Gravitation, F equal ma. Okay, so gravitational force is equal to G times m1 times m2 over r squared, right? And we are saying this is equal to, let's say, m1a. Okay, so m1 they cancel out, so a is equal to G times m2, which is the Earth, over r squared. Okay, that's a. That's the we call it the gravitational acceleration g. G is equal to m2 over r squared. Okay, so yeah, that's what Galileo was famous for. Acceleration is same regardless of the weight of this object. Okay, so it starts from 0. You have two objects, okay, something very light and something very heavy. It's not so heavy. How about this? I'm not gonna drop this, okay. Something very heavy and something very light, and you drop it at the same time. It has the same acceleration. So when they hit, both of them hit the ground, they're probably about the same speed. So they hit the ground almost at the same time. But that's not exactly true. Why? Because we are not in vacuum. Okay? So let's say, yeah, I'm sorry to complicate things like this, but it's important that you know this, all right? We are doing some basic science here, okay? Let's say you have one box, wooden box, okay? You have another wooden box. They're of the same size, same weight, empty box, okay? And you put 1-pound dumbbell in this wooden box, and the other one, you have 10 pounds of dumbbells inside the box, okay? And you put them into, you throw them into the sea or lake or your pond, and they both start to sink. Do they hit the bottom of the pond, your pool, at the same time? So you have two boxes, all right? They will both sink because one of them have dumbbells. Just just barely enough, uh, barely enough for it for this box to sink. Okay, this empty box is made of wood and it's waterproof. Okay, so if you don't put anything in there, it will be floating on the surface of this water, your pool, swimming pool. Okay, yeah, your parents, your grandparents, they're rich, so you have swimming pool. Okay, in your front yard. So you have this box, you put enough dumbbells. So it's initially empty box. Yeah, it floats around on the surface of your pool, the water. Okay, on the water, just like Jesus. All right, it's just it walks on the water. Okay, it's floating, but you start adding more dumbbells and dumbbells and dumbbells. So it start to sink. Okay, and that point it was you had like one dumbbell, and because your dumbbell is like 50 pounds. Okay, now you have another box. You put three dumbbells in there, 50 pounds. So together it's like 150 pounds now. These two boxes, do they think, do they hit the bottom of your pool at the same time? I give you like 5 minutes because it's been 30 minutes and we'll take a break, okay? I give you 5 minutes to figure this out. Okay, we are back. So, I'm on a as a side. I'm an Asian, so the only sports that I really enjoy watching is more like mixed martial arts, like martial arts. That's probably the only boxing. Yeah, boxing is okay, but I wanna see like mixed martial arts, like kicking, punching, elbow, like Muay Thai kind of stuff, knee kicks, jump kicks, and some jiu-jitsu, Brazilian jiu-jitsu. I really enjoy watching those things. Okay, probably because I'm Asian, and also the only ball-related games, sports that I enjoy watching is ping pong. Okay, that's very. I mean, table tennis is developed by the Westerners, but it's big in Asia, right? Or maybe soccer. Okay. Football or basketball, baseball, I don't really enjoy watching them. Okay, to me it's kind of boring. I don't really follow those games. Okay, so yeah, I have some Asianness in me. Okay, so I'm not gonna lie to you. Okay, it may make me politically unpopular in America, but not gonna lie to you. Okay. Anyways, so yeah, that's why I'm not good at catching this because we Asians we don't do that much. Like baseball, yeah, many Asians do play baseball. There's baseball league in Korea, basketball, but not much football. But I did play football a little bit when during the PT session or in U.S. Army, but it was okay. I wasn't good at it, but whatever. Okay, so where were we? We ended with a question. So what's your answer? Well, first of all, what was the question? Uh, so yeah, this heavy box and lighter box, they both start to sink. Which one do they hit the bottom of the pool at the same time? What's your answer? No, right? This isn't my opinion. It's about physics, so it's an absolute. There's yes and no answer. Okay, if you said yes, you are wrong. Okay, it's not politics. It's not religion. It's not philosophy. It's just there's only one right answer here. Okay, and actually, even in politics and philosophy and religion, there's only one right answer. Okay, because physical universe mirrors metaphysical universe. Okay, it's blurrier. Because metaphysical universe you cannot see things, but in physical universe it's easier. That's why humanology developed after all the physics, mathematics, chemistry, biology is done. Okay, biology is still developing, but in terms of physics, chemistry, we pretty much know everything. Okay, that we need to know. Okay, so biology, yeah, there's still a lot to go. Mathematics, it's yeah, we had this generalized plus operation. We covered this before. Yeah, there's some way to go, but physics, there isn't really much to do anymore. Okay, because what are they doing nowadays? Black matter, stupid dark matter, or not black matter, dark matter. Okay, or black hole. Stupid shit, right? There's all garbages. Okay, they are not knowledge. It's just like psychology. They're all garbages. Okay, black matter, dark matter. I'm sorry, dark matter, black hole. It's all garbages. Okay, I don't think there is such a thing as black hole or dark matter. It's all fiction. Okay, so somewhere in the universe, there's black hole, there's dark matter. I think also balloons, bunch of balloons. Okay, because it's not falsifiable. Just like I think his name is Karl Popper something. Yeah, if it's something you cannot prove to be wrong or to be right, it's not provable. Then you can say anything. There's this black box. Inside of it, there can be a cat or a mouse. You can imagine anything, but if you cannot open this box, then it's unprovable, unfalsifiable. Okay, so that's not a science. That's your imagination. Okay, it's not objective. It's only subjective. Okay, I think that's what dark matter or black hole theory. I think it's all garbages. So there's this crippled physicist in Cambridge, England. What's his name? Hawkins or something. He passed away, right? Well, I don't think he contributed a single thing to the world of physics because physics pretty much died with Einstein. Okay, there is no more physics. Okay, everything that came after Einstein was just bunch of garbages. Okay, because there is just we just know everything, pretty much. All right, there's no more to know in physics. Okay, practically speaking, because physics, all this fancy physics experiment, that takes a lot of just government money. You know, National Science Foundation, NSF money, but it's just waste of taxpayers' money. They just study, they don't study, they just imagine this dark matter or black hole, this something evil, right? They turn into the dark side because back, I think Einstein was the last physicist because he thought about light. Okay, again, it's kind of religious, like biblical concept, light versus darkness. And special theory of relativity isn't about relativity actually. It's about absolutivity of the speed of light. Like speed of light, like the truth, like Jesus, okay? It's constant, no matter who you are, regardless of frame of reference, okay? So that's the philosophical or ethical moralistic interpretation of the special theory of relativity, okay? Truth is truth. No matter who you are, it's same. It doesn't depend on you. It's invariant. Okay, it's not relative, it's absolutistic. It's not relativistic. Speed of light. It's time and space that is relative, okay? To preserve the absolutivity of the speed of light, the truth, okay? Anyway. So I'm gonna turn on the heater because I turned it off before the break. I'm getting cold again. So the theory of relativity is kind of misnomer. Einstein could have named it as the theory of absolutivity. Maybe it's not as catchy. Okay, but yes, the speed of light is absolute, and time and space kind of kneel down, bow down to the constantness of absolutivity of light, Jesus, God, truth, whatever. Okay, so whatever, man. Anyway, yeah, I have many friends when I was in college, and some of my friends observed that I didn't, but some of my friends, smart friends, observed that as you go here to here, it's like the integration, and if you go here to here, it's like differentiation. Okay, I didn't notice that he did. So yeah, I have many smart friends. Integration and differentiation. Okay. Yeah, good observation that he's smarter than me. In a sense, I was kind of tutoring him on the physics and mathematics, but he observed something. He was smarter than me in this observation. So no matter how advanced your knowledge is, because sometimes I used to be a computer programmer, right? But many times, people who knew nothing about computer programming, they told me about programming, about because they have different perspective. So because we are in a computer programming world, we are in a narrow tunnel vision, but they bring in different perspective, and they solve problems that I couldn't as a programmer when we were in encountered with this computer programming question. So people who know nothing about your own expertise field, they can actually teach you. Okay, so that's why Jesus said, "You're all students. Nobody is a teacher. The only teacher is the Holy Spirit." So yeah. Anyway, man, we're going everywhere again. Uh, well, yeah. So yeah, the answer is this. Okay, the in the swimming pool, heavy object falls to the bottom of the pool, hits the bottom of the pool earlier. Okay, it's because it's not vacuum. So when Galileo Galilei said this heavy object and lighter object hit the ground at the same time, if it is vacuum, okay. But if it's not vacuum, if there's air or water, then yeah, the mass, the weight actually matter. Okay, the heavy object falls faster. Okay, because it's because the attraction, this gravitational force between this heavy object and the Earth is stronger. Okay, so it can overcome the resistance of this medium e- more easily than this lighter object. Okay, so it has to do with this concept of friction. Okay, friction does depend on the mass, how heavy this object is. The heavier this object is, the more friction it incurs. Okay, so and also it depends on this surface shape and surface area. So friction depends on a lot of things. The surface area. If you have a feather, goes down very slowly. Why? Because it's a huge surface area. A feather, okay. But if you have this ball, marble, or a ball, or something spherical, and it's a solid surface like a ping pong ball, baseball, or basketball, or smooth surface like a bowling ball, okay? Because mathematically it's proven that a sphere has minimal, the least surface area of all shapes given constant mass, constant weight. You may have this clay, you can shape it any way you want, but if you make a spherical bowl shape with your clay, it has the least surface area. But if you make it like spiky, like a sea star or sea urchin, then it has a lot more surface area. Okay, it's the same mass, same blob of this clay, but the surface area can vary. Okay, the bowl shape, spherical shape has the least surface area. That's why your teardrop, water, rain, it has this spherical shape, because there's this electrostatic force in the water molecule, also gravitational molecule force, which is very minimal, very small. Electromagnetic force is a lot bigger than gravitational force. Okay, so the reason why we don't feel too much electromagnetic force, the reason why we don't experience it very much is because most all these objects are electromagnetically neutral. Why? Because if there's positive charge, then there's negative charge. They come together and they make it neutral. Okay, but gravitation, it's not like electrical force or magnetic force. In magnetic force, you have two poles, like north and south, right? Electrical force, you have two poles, plus or minus, right? But gravitation does not have that. It's unipolar. It's just mass. Okay. but it's a very weak, small force compared to electromagnetic force. Okay, so but we have gravity, right? That's why, and Earth is so big compared to us or objects we see. That's why it has a huge force, and because it's unipolar, uh, it doesn't quite neutralize each other like electric force or magnetic force do. So mass gather and then it just piles up, it adds up. So that's why uh, the gravity of Earth, because Earth as a ball, this huge spherical object, is huge. Okay, so although gravitational force is such a weak force, a small force, it has huge impact on us. Okay, because we are all mass. Okay, we don't have gravitational force. Do not have any polarity. Okay, so okay. If you are lost, don't worry. Just do some research. All right, it's not that important. It's giving you some basics. Okay. I'm just enticing you, inviting you to the world of science. Okay, so that you study and get smarter. Okay, don't be just all about politics and activism and religion. Yeah, study some science. Okay. All right. Okay, so we talked about this constant acceleration, meaning the force is the same. It's same gravitational force. All right, approximately. Now, but the speed changes. It was zero, then it gets faster and faster and faster, and then it gets very fast and it hits the ground. So, but the constant acceleration. So what is acceleration? Again, let's erase all these things. Okay. Well, before we talk about acceleration, we will talk about speed. We go back to one-dimensional space. The road, straight road. You have 0, you have 1, and you have 2, 3, okay? So your friend is right here, and he's going here. But if he's not moving, he's just sleeping at home, watching TV, sitting, couch potato or whatnot. He's just here. He's not moving. And you are here. So he does have this positional vector, okay? 1, that's his position. But tomorrow morning he wakes up, he get up, and he is moving from here to here, okay? And when he moves, he's a good guy, he abides by the speed limit, so and the road speed limit is like what? 35 mile per hour, 35 miles per hour, okay? Constant speed from point 1 to point 3. And let's make it easy. 30 miles per hour, okay? 30 miles per hour. And this positional coordinate is by mile, okay? So 30 miles per hour, okay? Meaning, and this is, he travels 2 miles. 2 miles from 1 to 3. Lucky him, he doesn't have to go all the way across town to work. It's 2 miles. The speed limit of this road is straight road, is 30 miles per hour. He always observes the speed limit. He doesn't go over or under, okay? He's a nice guy. He doesn't want to go too slow, okay? So, how much time does it take from point 1 to point 3? 2 miles. How much time does it take? We already had this, okay? S equal S0 plus V0t plus 1 over AT, right? Yeah, this is a equation that you use when the constant, the acceleration is constant. Here we have zero acceleration because let's simplify. Okay, so he's moving from point 1 to point 3, and we ignored all these minute details, so acceleration is zero, and also it's constant. Okay, so we can use this equation. Okay, so S equal 3. This is like ST, okay? ST. So when he started here, T1 is 0, or T0 is 0, so it's the beginning of the time. And how much time does it take from here to here? That's T2, okay? So the ending position S, the S stands for space, okay? So this like distance, okay, or this displacement, okay, position. So equal to S0 is 1 plus V0 was 30 mile per hour, 30 mile per hour, times T, we don't know T, that's what we are looking for, right? So T is equal to 3 minus 1 over 30 equal to, this becomes 2, right? And 2 over 30 is, if we cancel it out, 1 over 15 hour. Okay, what is 1 hour? 1 hour is 6. So this is equal to 1 over 15 times 60 minutes. 60 minutes. And you cancel that out, is equal to what? 4 minutes. Okay, 4 minutes. So yeah, it takes 4 minutes from his home to his workplace. Okay, 2 miles, 30 miles per hour, it takes 2 minutes. Okay, so yeah, that's the equation we just solved. All right, if you can follow this, you just go back to just Google around. Okay, this acceleration equation or velocity equation. It's basic physics. Okay. Okay. Now, because we want to talk about calculus, okay? So, sorry, this t squared, all right? Calculus, at the very beginning, I think calculus came about with physics, okay? Like Leibniz, he may have been more interested in pure mathematics, but Newton, Isaac Newton, he was also a physicist, okay, so great physicist. So he probably was motivated by solving physics problem, and that's how he came about this concept of calculus, okay. And then Leibniz is more like pure mathematician, right? He's in the continent, so there's continental philosophy and this British philosophy, Ireland philosophy. British, back in the days, we are talking about 1800s, 1700s, okay, right after this age of enlightenment, the age of reason in Europe, okay, that's where white people became the top ethnicity, top race of human world. Okay, the age of reason after Renaissance. Okay, Renaissance is a rebirth of this Greco-Roman, Middle Eastern knowledge, because white people before then used to be just barbarians. Okay, so they white people, these Northern Europeans, they invaded Europe, the Southern Europe, like Italy, Roman Empire, and then wow, they were wow, they're surprised by this great civilization of Middle East, like Egypt or Iraq, Iran, Persia, Middle East. Okay, that was the center of the civilization before white people took it over. Okay, so it was the Middle East, and then white people came in later, and they caught up through this crusade. This barbarian, brand new Christians, like this white people, Northern Europeans. Okay, they went to invade, like the Middle East, you know, to regain the Jerusalem from Islam's. Okay, that was like 1000 AD or 800 AD or whatnot, right? And then they brought back all these books, okay, from written in Greek, written in Latin, written in Arabic, okay, and then they also kidnapped a lot of scholars too. So they brought back to Northern Europe, and then they started to learn from Middle East, okay, the mother bed of human civilization, okay, and then they exported it out to Northern Europe. So they learned, they caught up, and then that's the Renaissance. Okay, so Renaissance is not anti-Christianity. No, it's not. Okay, so there were Middle Age, right? The Age of Darkness, Dark Age. It's because light was turned off. What was the light? Roman Empire. And Roman Empire later, the Emperor Augustine, he adopted Christianity. Okay, so Christianity was adopted by Roman Empire. So that was the light of the day, of the world. And but this ignorant, barbaric white people from Northern Europe, they invaded Rome, the almighty Roman Empire. So light is out now. So that's the start of Dark Age. Who started it? White people. Okay, white barbarians like Vikings and Visigoths and Vandals. Yeah, they're white people. Okay, so they invaded Roman Empire. So light is out. It's all dark now because the highly civilized Middle Eastern people were conquered by ignorant white people. Okay, so white people caused the Dark Age. All right, but later on, white people saw this Roman Empire, this Middle Eastern civilization, so they adopted Christianity. Okay, so Christianity was adopted by Roman Empire, and then later, white people came in, they destroyed Roman Empire, and white people, adopted Christianity. That was the beginning of the Dark Age. So Christianity was existing before the Dark Age. It was an official religion of Roman Empire since Augustine, okay, the Augustus whatever, the Roman emperor, okay, like Constantinople, right? Constantinople, whatever. So you have to understand this, okay? Dark Age is not caused by Christians or Christianity. That's misconception. That's ignorance. Dark Age was caused by white people, Caucasians, because they were barbaric. They invaded Roman Empire because they saw the light in Roman Empire and they wanted to tap in. Okay, just you have this smoothie and you stick this straw and you suck on it, right? You tapping in, right? So yeah, that's what happened. Poor people, barbaric people, ignorant people, they saw this great civilization down south in the Middle East, Roman Empire, Italy. Italy is not exactly Europe, okay? It's like Turkey. they're half Middle East, half Europe. Okay, so they saw the light, just like firefly, right? Then they came and they destroyed their soldiers and they stole this great civilization like gold, silver, this architecture. They just stole it. Okay, so that's the ancestors of white people. Okay, Caucasians. Okay, so yeah, so that's the start of dark age because light is out now. Okay, but white people look at looked at Christianity and they were surprised and they were impressed by Christianity, so they adopted it. That's the beginning of the dark age near 1000 AD or 800 AD to like 1400 AD, 1300 AD. Okay, so why dark age is nothing but white people catching up with the Middle Easterns, okay, the Arabs, Egyptians, the Jews. Okay, so white people trying to catch up and they adopted Christianity, but they are still barbarians. So they applied Christianity in a very barbaric way, like Inquisition or this ordeal where you punish people by or you try somebody whether this there's this accused this okay so you try somebody by you have this boiling water and there's this stone on the bottom of this boiling hot water jar. You so you are accused, you are kind of caught in some kind of suspicious act. You put your hand and you bring up this stone and in this boiling hot water and to see if your hand heals very well or not. That's ordeal. Ordeal. Okay? It's a trial by ordeal. Okay? So if your hand heal well, then you are innocent. Otherwise, you are guilty. Okay? So yeah, it's all this barbaric, also Christian, very harsh Christian because these white people in 1000 AD right after they conquered Roman Empire, they adopted Christianity, okay, but they're still barbarians, so they have their own version of Christianity, okay, and it was very barbaric. That's the Dark Age, okay. It's a barbaric Christianity by white people, the brand new Christians, okay, they adopted Christian, but they're still barbaric, so they applied these barbaric rules of upon Christianity. So they let's make some humanology equation here. Dark Age is equal to white barbarism plus Middle Eastern Christianity. Okay, that's the Dark Age. It's a brand new Christianity by white barbarians. Okay, that's Dark Age. It's not Christianity. No, it's white barbarian Christianity. That's Dark Age. Okay, nobody tells you this. Why? Because they don't know. Okay, because they are not humanologists. They cannot see the big picture. We do. We are all pattern recognizers. Okay, we recognize patterns. Okay, so we are not rewriting the history. We are reinterpreting the history in a correct way. Okay, so that's Dark Age, and after 500 years, white people caught up and they exceeded. Okay, and they excelled. So that's the age, 1500s, age of reason, and so the Dark Age was brought by the white people. Then white people caught up, so then they created the Renaissance. Let's go back to the past. Glorious past of Greeks and Romans and Egypts and Arabs. Okay, so let's go down south to the Middle East. After the Crusade, they brought up all these scholars and books. So they studied it. White people, they studied them. They rediscovered this great civilization of Greece and Roman Empire and Egypt and Alexandria, Persia, all this Middle East, and also Judaism, okay, Christianity. So yeah, they got enlightened. That's about 1500s AD, 1680. Okay, Age of Reason, Enlightenment, and Renaissance. Okay, so they caught up and they added something new. So that's the Age of Science. Okay, all this physics, mathematics, but they all started from Middle East. Okay, the Arabic number, Middle East, Arabs. Okay, and geometry. Is Euclid in Greece. Greece is not exactly Europe or white people. No, they are Middle Eastern mostly. Okay, they have dark shadow here. They have thick eyebrows and brown skin. They are not white people. Italians same way. They have thick eyebrows, brown skin, this dark eyeshadow. They are more Middle Easterns. Okay, they are not white people. Many of them nowadays want to be regarded as white people, but they're not white. Italians, Greek people, or Turkish people, they're not white people. They're Middle Easterns. They're Arabs. Okay. Jewish people, yeah, they're not white people. No, they're Middle Easterns. Okay. Yeah, they're more brown people. Okay, so they're not white. White people are the blue eyes, white skin, like blonde hair. They are the white people, like Northern Europeans. Okay, who used to be barbarians. Okay. Yeah. All right. It's a continuum of race. Okay, from you have Africa, you have Asia, you have Middle East. We have browns, dark browns, light browns in the middle. Okay, then you get wider and wider, just like polar bear and of North Pole. It's continuum, okay? Whatever. We're gonna take a break very shortly, but so basically, let's take a break now. All right, I'll be back. I'll be back. Thank you for being good friends of mine. I appreciate you being such good friends of mine. Okay, thank you. I'll be back. All right. I'm gonna ventilate the room a little bit, get some fresh oxygen, and get out the carbon dioxide. Let's ventilate a little bit. Okay. Okay, so we're gonna move on and to derive the generalized calculation of differentiation. Okay, so integration is just nothing but reverse process of differentiation. So if you're interested in integration techniques, whatnot, formulas, just look it up. Okay, we're not gonna go over it. It's just easy if you know differentiation. It's just a reverse process. All right, it's like multiplication and division, or addition and subtraction. Is if you know what addition is, you know what subtraction is. If you know multiplication is, you know what division is. It's something like that. Okay, so just reverse process. So we'll talk about differentiation mathematical way. Okay, so put on my turn on my heater and uh, if you have noticed, I'm kind of sensitive about this temperature because my body temperature is quite picky. I don't adjust to temperature very well. Okay. Uh, Maybe because I'm old, whatever. Probably not because I'm Asian. Just me. Other Asians are not like me. Okay, so yeah. Let's go through this differentiation. Okay, we'll derivation of differentiation. We'll derive differentiation. Okay, so it's like this. Okay, let's say fx is a function equal to x to the third. Okay, differentiation is this: f prime x equals to 3 slides down, and then you subtract 3 by 1, it becomes 2. That's the differentiation. It's that simple. Okay, this on the shoulder, this power comes down. Okay, and it goes one level down. 3 becomes 2. That's what differentiation is. And second differentiation, just do it one more time. Okay, now 2 slides down and it becomes multiplied. It's multiplied by this. 2 slides down, so 2 times 3 becomes 6, and 3 becomes 1, which is just 1x. Okay, third differentiation is this: 1 slides down and 1 becomes 0, and x to the zeros is 1, so it becomes, okay, so that's differentiation. Now, how do we derive this? All right, it's that's more involved than this. Okay, but we'll go over it because I mean, it's interesting exercise. It's brain teaser. It's brain exercise. You should not only exercise your body, you should exercise your brain as well. To be a good person, okay? To be more disciplined, all right? Be a scientist. Be a mathematician. Be a humanologist, okay? Because if you are gonna be a humanologist like me, or even better humanologist, you have to know everything. You have to know mathematics, physics, music, fine art, everything. Because humanology encompasses everything. Okay, you have to know everything. Little bit of everything. Okay, little bit, tiny, minute, little bit of everything. All right, so because that's universe. Human being is a microcosmos of universe. So in order to understand the universe, yeah, you have to understand human, and in order to understand human being, you have to understand the universe, everything. Okay, so otherwise you'll never understand human being. Okay, so all right, so let's go over this. Um, yeah, well, first of all, Leibniz, he came up with this differential symbol. Okay, but so V is according to the Isaac Newton. Newtonian symbol is this. Like V equals x was the position or location, right? X dot. But by Leibniz is this dx dt. Okay, acceleration is according to Newton. He used this symbol x dot dot. It's like you have this f prime f2 prime, right? Something like that. Okay, and by Leibniz it's like d squared x dt squared, but that's not exactly right. This is not an exact symbol. So some teachers they prefer to use dt squared. Okay, because this is same as dx dt d dt. Okay, so this is more correct symbol because mathematically this is incorrect. Okay, because if you substitute d squared as m or something, if you differentiate with m, the result is different. This is not dt squared is not the same as dt parenthesis squared. They are totally different things. Okay. Yeah, I came up with an example when I was sleep in bed at night last night. Yeah, they are different mathematically. So it's not exactly correct symbol. It's a misnomer. Okay. So anyway, well, I'm doing this just in case you know some mathematics. Okay, so if you know mathematics, you will probably are following me. Otherwise, either catch up or don't worry about it. It's not that important. Okay. Yeah, and it's this. All right. So we are using the example of y equal fx. See, I'm not very good at catching things. Y equal fx equal is a function. Okay, so polynomial function x to the third. All right. Y equal f is in the xy Cartesian coordinate. By Rene Descartes, great mathematician, great philosopher, French with his short mustache and long hair and whatnot, who impregnated a couple of different women, and he had daughter or something like that, whatever. Yeah, not very responsible. Because this kind of fornication, he didn't marry them, right? Kind of like Einstein also had extramarital children out of wedlock. Yeah, Einstein, Rene Descartes, they're kind of like artists, kind of somewhat promiscuous, like a Lex, in terms of sexual ethics. Okay, slept around and getting girls pregnant and kind of irresponsible. Yeah, creative people sometimes are like that. Okay, not everyone though. Like Immanuel Kant, Schopenhauer, they have been like celibates. Adam Smith, celibates, and there's one American president who was celibate. Buchanan, President Buchanan was. I mean, he's not very famous. I think he's a one-term president or something. But yeah, he was a celibate. He never got married or anything. Okay. Anyway, so yeah, Jesus was celibate. So y equal x x to the third. Okay, so it goes. It's very steep curve. Okay, so you have minus. Actually, it's steeper than that. Okay, so it's not to the scale. Okay, so minus 1 times minus 1 times minus 1 is equals to minus 1. Okay, so f minus 1 is equal to minus 1 to the third equal minus 1 times minus 1 times minus 1 equal minus 1. Okay, so this is x minus 1. You plug that in there into this equation, then this function, then you get minus 1. Plus 1 times plus 1 times plus 1 is 1, right? Now, we have, I'm sorry, okay, it's not to scale, okay? Let's say this is 2, okay? What is y? 2 times 2 times 2 times 2. Sorry, 2 times 2 times 2, 8, okay? So, what we want to find out is the slope. Oh my goodness, I'm such a horrible. And now, what's the slope? This straight line. So you have this curve, right? Slope is this tangent. The straight line that touches at this curve, at this point. There's a tangent. So what is a slope? Slope is this. You have this 45 degree, whatever angle, alpha, right? Or theta. Slope is this. It's this is slow slope, steep slope. Okay. How do you know? How can you express this degree? Okay. How can we quantify this degree? It's this. Given this delta x, okay, this difference, okay, delta x, this distance between here and here, difference between here and here. How much delta y, how much did y change? Delta y. Delta y1 is this, it's kind of slow. Delta y2 is here, it's a lot of change, okay? That's the slope. So slope, slant is, we'll call it, so we are talking about cubic equation, cubic function, but before that, we should talk about straight line, y equal ax, okay? A is the slope, right? My goodness, we're jumping all over, man. Back and forth, back and forth. I'm sorry. Let's take a break and let's start with the first order equation, okay? I'm sorry. Because not everybody in this audience watching this knows mathematics. It's not your fault. It's just that you're busy with other stuff. You had to drop out of school to work for your parents or to feed your child. Who knows? Okay, things happen. Okay, and I don't want to exclude you. I'm not an elitist. No, I'm a very democratic person. Okay. So I want you to learn. If you already know this, then it's pointless. I want you to better yourself. I want to educate you. That's why I'm here. To share something that I know and you don't know. Okay? So we're gonna take a break and we'll step back and start from the basics, okay? Alright. I'll be back. Yeah, I wanna be inclusive. I'm very liberal and democratic party kind of person. I'm very inclusive, okay? I wanna include as many people as possible, okay? So it's a good thing, okay, to be inclusive. I'll be back. Okay, we're back and just chat a little bit. Okay, chitty chat, small talk. Okay, it's kind of weird dealing with mathematics. Kind of heavy, right? This is different language. It's like foreign language. All right, so it's uphill if you are not familiar with mathematics. So let's take a break. Okay, so if you're a Christian or if you know somebody who is Christian, sometimes we fantasize a lot. Christians, okay, we sometimes we fantasize we are like David, King David, or we are like Jesus or John the Baptist or Abraham or Noah. Yeah, we fantasize many things. Okay, so sometimes we Christians think that God love me or you, Christian, more than anyone else. We are God's. I am God's favorite. Okay, so like nowadays, so many women they do tattoos and piercings, and I find them ugly. Tattoos and piercings. So, and many of them are obese, and so it's not easy to find a woman that I find attractive. They tattooed, pierced, obese. So, um, that's one of many reasons that I'm still single. Yeah, another reason, big reason is I'm poor. I don't have money, power, fame. I'm nobody, and another reason is I'm ethically upright. I don't compromise in the moral sense, and I'm straightforward. Like I talk my mind. I don't lick their boots. I don't kiss their asses. I say if you have piercing, this girl, I say I don't like piercing, and it's over. Okay, that kind of stuff. Okay, and I don't want to get STD, so I talk about, hey, do you have STD? Girls just run away. What kind of stupid Asian ass man, poor guy, asks such questions, personal questions? My goodness, I don't want him. So yeah, I'm single. Okay, I never get a date. But in a way, it's kind of fortunate for me because I can spend time with humanology. So maybe God loved me. God loves me more than anyone else. So girls, maybe that's expendable. So maybe God throw in this tattooism, piercism to the world so that I stay single and focus on this development of humanology. Because if girls are attractive, then I would be dating them. I would spend time having sex with them. So I wouldn't be spending time with you here doing humanology. Because okay, if girls have no tattoos, no piercings, no obesity, no marijuana, no lesbianism, no malefeminism, then yeah, I would just spend time dating them, kissing them, hugging them, touching them, having sex with them all day, all night long, whatever. So I will be spending time here doing humanology with you. Okay. So maybe God loves me or humanology more than anyone else. That's why God sacrificed all those girls by infecting them with tattooism and piercism so that I don't get distracted. One theory, okay? And there was another thing I wanted to talk about as a side. What is it? So Christianity, yeah, Armageddon. Okay, I don't believe in Armageddon. Yeah, it thought the book of Revelation talk about Armageddon. This destruction of world, whatnot. I don't believe in it. Well, I don't want to believe in it. It may happen that way, but I don't want it to be that way because if you are Christian, you believe that Jesus' death and sacrifice was enough. It's enough to save humanity. It's unnecessary that people die. Because Jesus, if you're a Christian, you believe that Jesus' death can save the humanity. I want to believe that. Okay? It would be nice. No one else has to die. Because Jesus was big, the Son of God, so he came down with high potential energy coming down to us and died, and so this huge kinetic energy, so he can save everybody because he was so high up there. Okay, huge potential energy. So yeah, no more death is necessary. Nobody else has to die. So that's what I want to believe, and that's actually the essence of Christianity. Okay, so I don't want there to be Armageddon and apocalypse. I don't think that's honest. I don't think that's necessary at all. I hope that never happens. Okay, so that's my personal point of view, and but hey, I don't know. I don't know what's gonna happen. I just hope it doesn't happen. The Armageddon, this apocalyptic way. I don't want people to die. Okay, I want them to just believe in Jesus and get all saved, all of them saved. Okay. Anyway, let's get back to the topic. Okay, so y equal. Let's start from the very basic. Y equal x. Okay, x axis, y axis. Fx is a function. Y equal fx equals x. Okay, so x is 1, then y equals 1. Okay, 1, 2, this is x, and this is y. Okay, now let's say y equal fx is equal to 2x. Okay, so f1 equals 2. 2 times 1 equals to 2. It's steeper. Okay, now x is 1, then y is equal to 2. X is 2, y equals 4. Okay, this is slope. It gets steeper and steeper and steeper. Y equals 2x, 3x, 4x. Okay, now this is the slope. We generalize is y equal ax, and a is constant. X is independent variable, y is a dependent variable. Okay, so a is a constant. It's called coefficient. All right, it can be 1 or 2 or 3. Okay, and or negative 1, negative 2. Now a is equal to y over x, right? X cross over this equatorial, this equation, this equality symbol. It crosses the border and it goes under, just like illegal immigrants. Okay, you cross the border and you go under, right? Okay, and you become some kind of like slave, lower class, physical labor, whatever, less than minimum wage, you go under. Okay, so I'm just connecting the political science and mathematics. Okay, it's a joke. Okay, don't get freaking offended by this. We are talking mathematics. How can you be offended? Okay, don't get offended so easily. Be more rational than emotional. Okay, it's just a joke. Now, that's the first order. Okay, it's not x squared or x cubed or anything. Okay, but you're gonna erase a lot. Okay. I'm poor guy. I have only one whiteboard. Okay, I cannot afford to have this big whiteboard and wide screen. Now, y equal x squared. Y equal x squared. Okay. Okay. You have x and y. Okay. If x is 1, x is 1, and 1 times 1 is 1. If x is 2, 2 times 2 is 4. Okay, this y equal x squared. Alright? Now, what's the slope? Because it's no longer straight line, but it's a curved line. Okay? What's the slope? What is slope? Is this tangent, the slope of this tangent straight line. Okay? We have this tangent line. My goodness, it's so messy here. Okay, so tangent line is straight line that meets this curve at this one point. what's the tangent line here? It's a straight line. Okay, it's a curve. Okay, so we want to find the slope of this tangent line. That's the concept of this differentiation. Okay, so it happened that this tangent line is nothing but y prime, which is equal to 2x. Okay, so this slope of this tangent line at 1 is equal to 2. Yeah, it is 2. Y prime at 1 is equal to 2. Okay. And y prime at x equal to 2 is equal to 2 times 2 equals 4. Okay, so I really need to do some better drawing here. Okay, so oh my goodness, I'm drunk and everything's falling apart. Sorry. Because we gotta plot two different functions. Okay, can you see this well? Okay, so you have x-axis, y-axis, all right, and then you have this straight line, 45-degree angle. This is y equal x. Okay, then you have 1.1, you have x, y, 0.1, right? And then we have this grid. Okay, then you have y equal x squared. It looks like this. This is goes like this, y equal x squared. All right, as you can see, the slope at this point, the tangent line slope of y equal x squared, it should be steeper than 1. Y equal x is 1 times x. So the slope of this straight line of this function y equal x is 1. But at that point, the slope of y equal x, okay, well, first of all, let's differentiate this. Y prime is equal to 1, right? You have 1 as the power, and it goes front, and 1 becomes 0, and it's 1 times 1 equals 1, okay? But if you have y equals x squared, this curved line, this parabola, y prime is equal to 2x, so y prime of 1 is equal to 2 times 1 equals 2. So that's the slope of this parabolic curve at 0.1, okay? It's 2, it's steeper, like this, okay? If you cannot follow me, you have to catch up by Googling, Binging, you know, just do online search of slope and differentiation, then you will get it. Okay, it's not that hard. Now, I'm sorry if I'm going fast, but you have to understand. We cannot. This is not a mathematics like algebra or Cartesian geometric algebra class. This is a humanology class. Okay, so I cannot spend the whole time doing mathematics, but I'm doing as much as I can. Okay, so let's say you have this curve. Okay, and before we get into this, we have to understand the limit mathematical limit. Okay, but well, maybe we just do it as we go along. Okay, so you have this 1 point and you have this. Say this is straight line, okay? You have x1, x2, y1, y1, y2, okay? Instead of 1 over half is y2, y2, y1. So, slope of this straight line is x2 minus x1. But this is how Koreans write, or Asians. We write the denominator first and numerator. But you Americans, you Westerners, you write the freaking numerator first. So it was so confusing at first when I came to America in college. It was so confusing. Okay, so that's the slope, A, okay, over this straight line. Okay. Now, the slope of this at this point and x1 is this. Limit x2 approach to x1, y2 minus y1 over x2 minus x1. Okay, so that's the slope at this point. Let's call this A, the slope at x1. Okay, and it's just same as limit delta x is approaching 0, delta x, delta y. Okay, what is limit? It's again, you can look it up. Okay, so you have this you have something like this, right? And you want to find your eventual goal is to find the slope of this tangent line here. But to do that, we go at it in an indirect circumspect way. Okay, forget about this. This. Okay, so the slope was this, and then this, and then this, and then we do this. Okay, to find the slope of this tangent line. All right, I don't think there's any way to make you understand this if you don't know mathematics. You have to do some Google search, okay? Because I'm only a human being. I only have limited time. I haven't had dinner yet. It's like what, 10:30 at night, and I had some snack. But so yeah, I cannot spend too much time doing this. But okay, so do some Google search. We take a 5 minutes break, okay? Then we're gonna erase all this, and we'll move forward to derive the differentiation. Okay, so we're gonna talk about this, but it's too much, right? So let's take a break, do some Google search, or just relax. Okay, we go to the next, move to the next step. Okay, I'm sorry if I'm moving too fast. All right. Okay, we're back. Where's my slippers? Oh, it's over there. Okay. So why are we doing all this? Because am I showing it off? No. It pains me that you are not following me. Okay, it bothers me that you are not understanding this because you need to know mathematics and physics. Okay, you need to know science because all these liberals, they say they love science, but they don't know science. Okay, that makes me sad. Okay, you need to know science. All right, so I want you to just observe how beautiful science and mathematics can be. Okay, so yeah, it's pain in the ass at first, but you can enjoy it once you know it. Because I learned this like 2 decades ago, more than 2.5 decades, 25 years ago. Okay, I learned this in middle school in Korea, South Korea. I still remember these things, okay? Because it's like language, mathematical language. Once you know it, you don't forget it. It's like learning a bicycle, okay? Yeah, and you enjoy this, okay? Yeah, am I enjoying? Yes, okay. So you don't have to smoke marijuana, do cocaine or opium or all that. Opium, yeah, it used to be legal in Hong Kong. So British people, this British Empire, yeah, they sold opium to Hong Kong and China, and they made a lot of money with it, but it was not good. That's what America is doing right now, right? They sell marijuana and people get high, and the nation is going down, but they make money, right? Selling out, whoring, prostitution, same thing, okay? They sacrifice morality and well being of the people just to make money. Selfish. Bad. Donald J. Trump and all the other politicians, they go along with it. They don't care about America, future of America, American generation. They only care about their re-election or election. So sad. That's why I'm running for president in 2020, okay? Because I care. Probably I'm the only one who care. If you care about America, your kids, grandkids, you have to vote for me, okay? Yeah, there is this election law. I told you last time, like, yeah, just cross out the stupid names and write my name, write in election, write in voting, but it may be against the election law because to be a write-in candidate, I think you have to get like some 10,000 signature or 1%, 5% of the population or something. I'm not gonna do that. No, too much work. I'm lazy. All right, so just vote for me. So for whatever way, okay? Because if everybody vote for me, then I'll be able to ignore it. All right, so just vote for me, okay? And so yeah, we have to erase all this, okay? So yeah, because I am determined to cover this and get to the bottom of it. All right, so we'll talk about Pascal's triangle. Okay, this another. It has to do with combinatorics too. Okay, so combinatorics. Pascal's triangle is like this. Okay, 1, 1, 1. You put one on the edge. It's triangle. Then you add up this two above you. 1 plus 1, 2. You put one here, and you add up these two things above you. 1 plus 2, 3. 2 plus 1, 3. Okay, and 1, 1. 1 plus 3, 4. 3 plus 3, 6. 3 plus 1, 4. Okay, so it's called binomial coefficient. All right, so I'm going to turn on the heater and put on my jacket. Yeah, and in statistics, there is what's called binomial distribution, okay? It's kind of like Gaussian curve, kind of like primitive form of this bell curve, normal distribution, whatnot, okay? So in the middle you have big number, okay? Let's do one more, okay? 1, what is it? 5, 10, 10, 5, 1. It's symmetrical, okay? So in the middle is a big number, at the end it is a very small number. So it kind of looks like this. Bell curve, Gaussian curve. Gaussian curve has some fancy integral and this E natural number 2.73 blah blah blah, right? By the way, what is E natural number? Euler's number. You have y equal e to the x, okay? It's a power function. So y prime is ex and y2 prime is ex. So it's very unique function where no matter how many times you differentiate it, it stays the same. It's like a identity. It's like no matter what number it is, x times 1 equals x, right? So x times 1 times 1 times 1 times is always x. So x plus 0 plus 0 plus 0 is always x, right? So e is like e to the x is kind of like that in terms of this differentiation. Y to the n is stays same, x, e to the x, okay? So it's kind of like identity in terms of differentiation, all right? Okay, so is this binomial coefficient, okay? So a plus b to the 0th equals 1, right? A plus b to the first is a equals a plus b. A plus b to the second is a squared plus 2ab plus b squared. 1 to 1 is a binomial coefficient, okay? Because why binomial? Because there are only two elements here. A plus b to the third is equal to a to the third plus 3 times a squared b plus 3 times ab squared plus b to the third. 1, 3, 3, 1. 1, 3, 3, 1. It goes on and on like this. Why? It's because a plus b to the nth is equal to sigma. You should be familiar with sigma summation, okay? I is equal to is it 1 or 0? Okay, well, a to the n minus, okay, so 0 to n minus I, b to the I times this is binary coefficient, okay? If it's n I, let's see. Yeah, 3 to the 0 is 1, yeah, n c I, okay? This c is the binary coefficient, okay? So, for example, n is 3, okay? So 3c 0 is 1, 3c1 is 3, 3c2 is equal to 3c1, then 3c3 is 1. So 1, 3, 3, 1. Yes, yes. Okay, so this binary coefficient, what is C? It comes from combinatorics. Combinatorics, okay? C means combination, okay? Out of 3, how many ways is there to just pick nothing from it. Only one way, okay? Out of three, like A, B, C, three, how many ways you can pick only one of them? There are three ways, so A or B or C. How many ways are there where, out of three balls painted like A and B and C? Azure blue and cyan, kind of all blue kind of hues, but pick two. Yeah, it turned out to be same as this, okay? Because in combinatorics, NCX plus NC N minus X is equal to, no, these are equal, okay? So if you add these two up and they become n, then they tend to be the same. So that's why it's symmetrical, okay? Yeah, if you don't understand, if you're not following me, just look up the combinatorics binomial coefficient or Pascal's triangle or Pascal's triangle, okay? Then you'll catch up, all right? It may take some time, okay, but I want you to catch up, okay? All right, so we have to erase again, okay? Because we're running out of space and I'm getting hot, so let me take off my jacket, turn off my heaters again. Oh boy. It's preliminary stuff. I'm not just doing this to show off. No, I'm doing this in sequence, in the right order, to build up the preliminary stuff, to understand what the mathematics of differentiation, which is the building stone of calculus. I want you to understand this, okay? Because something very beautiful, and I want you to appreciate it, okay? All right, wow. We don't go, oh, so many different stuff. All right. So let's say y is equal to x squared, x cubed, x to the third. Okay. So that's y. All right. So now, which looks like this. Okay. Kind of looks like this. That's y equal x squared. I mean x to the third. All right. Now, here is x1. We want to find out the slope of this tangent line. Okay. And it's this x1 and this x2, y1, y2. Okay, so slope of slope tangent line, slope of the tangent line in x is equal to y prime at x1. Okay, which means limit x2 is approaching to x1, x2 minus x1, y2 minus y1. Okay, and which is equal to limit x2 x1 x2 x1. Okay. I'm I'm sorry. It's correct, but it's not convenient to see it this way, okay? You have this, okay? Let's say this is x, and this gap is delta x, okay? From here to here, delta x. This one is x plus delta x. And you have this slope here. The straight line, they connect these two, okay? This one is fx. This one, x plus delta x. Okay? X plus delta x. Now, slope, which is f prime x, is equal to delta x. And then you have f x plus delta x minus fx, which is same as delta y, okay, because y equal fx, okay, so delta x and delta y, that's the slope, right? Delta y over delta x, that's the slope from x to x plus delta. Okay, that's the slope of this line. It's not tangent yet, okay? What a mess. Let's just call it A, okay? The slope A, okay? Slope A. Between these 2 points, all right? Now, slope of A in this tangent line at the point x is f prime x is equal to limit delta x is approaching to 0 and delta x, then you have x plus delta x minus fx, okay? You know, I'm not a good mathematics teacher here because that's not what I do for a living. I'm just jogging my memory from 2.5 decades ago, 25 years ago. I learned this in Korea. Okay, so you have to forgive me for not being a good mathematics teacher because it's not what I do every day, okay? So that's why you should pay attention in your school, okay? Because I'm not a good teacher, okay? I'm not a professional teacher, all right? So that's why I'm not being good at this, okay? So we're gonna have to erase again, but in school you have this wide screen, big blackboard, green board. But me, I'm on a shoestring budget. I have this tiny mini whiteboard, okay? So I have to erase it again. Okay, so f prime x is equal to limit delta x is equal to 0, but it's correct, okay? At least you should give me credit for that. After 25 years, man, come on. Delta x minus fx over delta x, okay? And what is this? Limit delta x goes to 0, delta x, and now we have this polynomial. Remember, fx equals to x to the third, right? X plus delta x to the third minus x to the third, right? Is equal to limit delta x go to 0, delta x to the third plus 3 times x squared delta x plus 3 times x delta x squared plus delta x to the third minus x to the third right here. Okay, so this one and this one cancels out. So limit delta x go to 0, delta x 3x to the third second delta x plus 3 times x delta x squared plus delta x to the third is equal to limit delta x go to 0. Now this cancels out, so 3x squared plus 3x delta x time plus delta x to the second squared, then big parentheses around it. Now delta x is going to 0, so this goes to 0, this goes to 0, and the only thing that remains is 3x squared. Okay, so that's why x to the third prime, like differentiated in terms of x, is equal to 3x squared right here. Okay, so we just n to the nth, like x to the nth is just x to the nth prime is equal to n times x to the n minus 1. Okay, so I'm just giving you an example. Okay, so this is differentiation, right? So okay, we got it done. Okay, whether you followed me or not, at least we can say to the world that I tried. Okay, so if you don't follow me, that's fine. Just Google around, and you know it's free. Go to YouTube and Wikipedia, Google, Bing, all different websites. You can follow this. It's a great hobby. Okay, so you don't need copium. I mean, copium. You don't need opium, marijuana, all these drugs, gayism, tattoo piercism. No, you don't need all that stuff. You want some challenge, you want some pain, learn science, learn mathematics, and you'll have fun. Okay? I want you to be constructive and not destructive. Gayism, tattoo piercism, obesity, sugar fatism, they're all toxic, they're self-destructive. Marijuanaism, opiumism, they're all self-destructive, okay? It destroys you. But learning mathematics or new foreign languages, mathematics like foreign language, right? Physics, it's fun, it's painful, so if you want some good pain, yeah, go out and exercise, do run, and do like weightlifting and learn martial arts, dancing, okay? That's what I recommend you to do, because something constructive is good for you. Okay, so you don't have to be self-destructive like gayism, tattoo piercism, sugar fatism, marijuanaism. It doesn't have to be that way. Okay, you can suffer in a good way, constructive way, by learning something new. You can challenge yourself. You don't have to put this needle, tattoo needle on you. You wanna have fun? Yeah, just do learn these good things. Okay. Are you following me? All right. You better. This is very important. Okay. I'm doing this for you. Okay. I'm not doing this for myself. All right. It's like 11 o'clock right now. Okay. And I don't get paid for this. All right. I'm doing this all for you because I care about you. Unlike Donald J. Trump or any other politicians, I care about you. Right. Okay. So why are we doing all this? It's all this. It's because Jesus said, you know, don't like don't strive to be rich. Okay, you don't. If you're gonna build wealth, riches, don't build wealth on earth. Build wealth in heaven. Okay, that's what Jesus said. Okay, look it up. I don't know. It's probably Matthew, Luke, Mark, John, somewhere. Maybe all of them. Okay, so don't focus on the building wealth on earth. Like, don't try to make too much money. Okay, rather build wealth in heaven. So don't be more like physically wealthy, be metaphysically wealthy. That's what Jesus said. That's a humanological interpretation of that. Meaning, if you have time, don't try to make more money. Rather, try to be more knowledgeable. Educate yourself. Be rich in heaven, metaphysical level. Be more knowledgeable. Learn mathematics, learn foreign language, physics. Okay, it's free, and nobody can steal your knowledge. It's not like they can like put a hole on your skull and put a straw and then suck up your knowledge. No, nobody can do that, right? But if you, Jesus said, if you build your wealth, your riches on earth, then people will come and they will steal from you, like thief. You know, they steal from you. If you are rich, if you have a lot of money, yeah, they'll come and steal from you. Okay. So yeah, that's the whole point. Okay, so because money, we said, okay, there's this location, right? And then there's this velocity, and then there's this acceleration. Okay, velocity equals what? Right? The displacement difference over time difference. That's the velocity. Acceleration is difference of velocity over difference in time. Okay, so money. Okay, so this first level, second level, third level. Okay, money. You have this pot of money, like $10,000 in your banking account. That does not make you happy. Maybe if you increase the money, constant speed, your money goes bigger and bigger. Maybe you will be happy for a while because your money is increasing. Maybe you get your interest in your savings account, or maybe you get promoted, and so you have constant speed of increase. That's velocity. Your money is getting bigger and bigger. Your savings account is getting larger and larger, but on a constant speed. So you'll be fed up with it. No, so next level. So yeah, this constant speed of increase in your money level does not make you happy anymore because you are just used to it. So next level, what do you want? You want acceleration in your money increase. Like, say in this second level, okay, first level you had $10,000 in your banking account for forever, for a decade. It's always $10,000, constant. For a while you're happy, but later on you got old, jaded, so you want some more. So now you want constant speed. You want your savings account to be increased by 1% per year or 10% per year. Every year, like compound interest, whatnot, your savings account increased by 10% every year. Okay, for 10 years, all right? So it's constant speed. But after 10 years, it's all the same. So it's been like that for past 10 years, for a decade. So I want something more. So third level, you want this acceleration. Okay. You want your savings account to be increased by this constant acceleration. So the first year it is like 10%. The second year you want it to be by like what, 12% interest. Third year you want it to be something like 14% increase. Okay, so every year, year after year, it's like a 2% acceleration. Okay, so you got the concept, right? So, but after a while, you're not satisfied. Okay, that's exactly that fucking Donald J. Trump. He got all the money. He's not happy. That's why he ran for president, because he wants something more than money, something more than women. He divorced like 2 times. He got two ex-wife and current first lady. So he had 3 wives. How many women has he slept with? Probably in the hundreds, right? Adultery, fornication, right? He doesn't give a fuck. That's not just Donald J. Trump. There's Matt Lauer, Harvey Weinstein, all these big politicians, CEOs, the Hollywood celebrities, and all these rich and powerful, famous people. Guys, they are like that. They want more money, more women, and Donald J. Trump. I had all the women I wanted, and I have all the money I want. I had all the luxury I want. So what more do I want? I have all the fame and money. What's left? Power. Okay, that's why he ran for presidency. And stupid people like you and me, we voted for him. Okay, so now we are fucked. Okay, What is he doing? All he's doing is to prove himself. I'm a powerful guy. I'm going against China. So tariff and I'm so powerful. I won second election and look at this stupid Asian guy in Alaska. He's running against me. Oh, he's smarter than me, so I'm gonna kick him out of this country. Of course, I'm just saying he doesn't know me. Okay, it's just his immigration policy, extreme vetting. Okay, at first I liked it, but now he's coming after me. I mean, his policy. He doesn't know me. Okay, so yeah, he does not know me. I'm nobody. I'm unknown. So he doesn't know me. Okay, so nobody knows me except my friends and families. So I'm just joking, okay? But yeah, it's not just Donald J. Trump. It's Barack Obama. They're all the same, okay? All these Pope Francis, okay? All these big and famous people, okay? They want more and more and more. It doesn't satisfy them ever. Why? Because their heart is on earth, physical level. Money, power, and fame. Physical level. What is fame? It takes your memory, okay? Recognition. It's like taxation, metaphysical generalized taxation. That's fame. Power and fame, pretty much the same thing. Money, yeah, it's taxation. You take many people's dime and nickel and dollar over millions. That's how you become a millionaire. You sell a product, just like Sam Walton, okay? Yeah, you sell product and you make profit $1 over millions of people. Then you become a millionaire, okay? It's like taxation, all right? So selling product or government taxation, private corporation selling product or government, federal government taxing people, same principle. Okay, it's a pyramid, food pyramid. Okay, $1, $1, $1, 1 million times become $1 million on top. Okay, fame, same way. We have 1 million viewers, audience, ticket sales. Let's just say this movie ticket is $1, or this DVD or movie is $1. But 1 million people are watching your movie, and you become a movie star. You become a 1 millionaire. Okay, because we have 1 million people buying these tickets and DVDs, $1 each. There are 1 million people. So you become a millionaire Hollywood celebrity. Okay. So it takes memory of all these people. How do you become famous? It's not money, but it's memory in 1 million people. Very small space in your brain is the memory of that celebrity. Pope Francis, Donald J. Trump, Matt Lauer, or journalist, or Lady Gaga, or this Hollywood celebrity, okay? Very small space in your brain, piece of memory, but there are millions of us. Okay, that's how you become famous. Do you see it? Do you see the power of humanology? We are combining everything into one general principle. Triangle. Okay. Okay, good night.